Suppose a production line operates with a mean lifting weight of 16 ounces per container. Since over or under filling can be dangerous, a quality control inspector samples of 24 items to determine whether the filling weight must be adjusted. So N is 24. Chapter 7 and 8 review. We're doing number 1. N is 24. The sample revealed a mean of 16.32 ounces. So X bar with a sample standard deviation of 0.8 ounces. Don't put sigma, guys. He said S sample standard deviation, 0.8 ounces. Using a 0.10 level of significance can be concluded that the process is out of control, means not equal to 16. So alpha is 0.10. So we need to test, guys, this, going back to chapter 7, that the mean is not equal to 16 ounces. That's the claim. And can you guys tell me what the null hypothesis would be in this case?
Equals.
Equals. And this is a t-test, guys. Why? Because of S here. Give me S, I run a t-test. Okay, let's run the t-test. Number 2. It's a summary. Okay. What we're testing against, we're testing against 16. So you just put 16 right here. And X bar is 16.32. S is 0.8. N is 24. And we're testing that the mean is not equal to 16, not equal to. That's the alternative. Before you hit calculate, guys, you look at the HA and you put the sign from there, no matter what the sign is. So T is 1.95 and 3 decimal place is going to be 1.96. And p-value, as you noticed, is 0.0623, which is less than alpha. And if it is less than alpha, we reject HO. And if we reject HO and the claim happen to be in HA, we support the claim. So you say there is enough evidence at the 0.10 level of significance to support the claim that the process is out of control. So does the machine need to be adjusted or not, guys? What do you think? Yes or no? A quality control inspector samples of 24 items to determine whether the filling weight must be adjusted.
Yeah, it needs to be adjusted.
Yes, it does. It does need to be adjusted. This is how they figure this out, guys. This is the mathematics that they do. Because the machine should not be over or under fill. Well, if it is different from 16 and we supported that, that means it could be more than 16, it could be less. This is where they need to readjust the machine. So let me just put the filling weight should be adjusted. All right. So that's number one, guys. Let me pick now a question from chapter 8. We're gonna do number 3. Let's do number 3 together. Marla is studying the sodium content of cold cuts. A random sample of 8 52-gram samples of smoked beef produced a sample mean of 14.04 grams with a sample standard deviation 0.5. So it's S. And when he says S, forget about the Z distribution. It has to be a T distribution, guys. So Q3, let me just write them down, and then we'll work it together. So we have the first sample, N1 is 8. It has a sample mean X1 bar of 14.404, and S is 0.5. An independent random sample of 6 52-gram samples of smoked turkey, so beef and turkey. N2 is 6. Produce a sample of 13.52, guys, as you can see. So X2 bar is 13.52. And standard deviation S2 is 0.75 gram. Test to see if there is a difference in the sample mean sodium content of the above brands of smoked ham and smoked turkey. Use a 5%. Oh, I said beef and then ham here. Should be beef. And smoked turkey. Use a 5% level of significance. Assume that the population variances are not equal. All right, guys. So alpha is 0.05. And population variances are not equal. Can you guys remind me what population variances are not equal mean to us when we use the calculator? Yes? What does it mean when you use the calculator? We're gonna do pooled as what?
No.
No, because you say population variances are not equal. All right, let's do it. So since he gives me S1 and S2, guys, it's a 2-sample t-test. The 2 samples are independent, so it will be 2-sample t-test. And population variances are not equal means pooled, we select no. So HO, he says if they are the different. So mu1 is different from mu2. Just to show you again why I'm selecting this. He says, test the claim to see if there is a difference. Difference means not equal to, guys. So that would be claim. And mu1 equals mu2. All right. So get your calculator. There you go. Let's run the test. So stat. To sample t-test. Not data. We have summaries. Okay. So X1 bar 14.04. S1 0.5. N1 is only 8. X2 bar is 13.52. S2 is 0.75. 6. No questions, I'll proceed. See, the arrow is pointing down, means it's asking me to scroll down. And now we need to check if mu1 is different from mu2. There is one more. Pooled. We said no, because he says assume population variances are not equal. And hit calculate. And here you go. T is 1.471 and the p-value is big. And if you want to see how this works, guys, if you do a graph, not this graph. That's something probably I put in the calculator from, there you go. Ignore the first one, that shouldn't show there. Yeah, that's why. If I go to stat now, and I can show it to you now. I shouldn't see the other graph. When you see too much shading, guys, the p-value is going to be big. You're going to fail to reject HO. Remember, p-value low, HO must go. So now you have a T is 1.471 and look at the p-value of 0.1785. All right. So it's bigger than alpha. Fail to reject HO. Okay, here's what I said when we fail to reject HO. We start with there is not enough evidence at the 0.05 level of significance to support the claim that the two means are different, that there is a difference in the means. You just cut it and paste it from the question itself. So we say we cannot support that there is a difference in the means. So probably the means are not different, they are the same. Okay, so that's a question 3, guys. Okay, let's do another question. Question 4. Let's read this together. A pilot study in Fairweather County wishes to determine whether mailing reminders to register to vote to all citizens in the county who are eligible will improve voter registration. A random sample of 1,500 potential voters was taken. Then this sample was randomly divided into 2 groups. Group 1 consisted of 75 people. Reminders were sent in the mail to each member. The number from this group who registered was 405. So they sent a reminder to register to 750 people who are eligible to vote, and 405 registered. So let's write it down right here. So number 4, group 1. So N1 and X1, guys. N1 is 750 and X1, the number of successes were 405. Group 2. Don't let the length of the problem scare you. It's a very straightforward question. Group 2 consisted of 750 people. No reminders to register were sent to them. The number of potential voters from this group who registered was 375. So reminder no reminder. They want to make sure, they want to check to see if it makes a difference to send a reminder to people or not. That's the idea of the question. 375. Let P1 be the proportion of voters who registered, and P2 the proportion of voters who registered from group 2. So in group 1 and group 2. Test using a 5% level of significance to see whether the claim that the proportion of potential voters who registered was greater in group 2. Sorry, was greater in group 1. Not in group 2. Okay, in group 1. That was a mistake from my side. Okay, can you guys tell me? So we need to check if the proportion of people who voted was greater in group 1 than group 2. Can you guys help me state the null and the alternative hypothesis? So it's a P1, it's a proportion, not a mean. There are no means here, no standard deviation. So how do you, you need to state the alternative first, because he says, test to see whether the claim that the proportion of potential voters who register was greater in group 1, who will send the reminder. So greater, there will be this sign, guys. And that's the claim. And that will be less than or equal. Can a student remind me of the name of the test here? What is the name of the test, guys?
Two-sample proportion test?
Yes, very good. You're not gonna miss it, guys. Let's go here and you're gonna see it. Look. It's on the same first. In chapter 8, all the programs are on the same, the first screen. So it is 2 proportion Z test. The 2 means 2 samples, guys. The 1 means 1 sample. That's so 2 proportion Z test. I'm gonna click on it. And X1, 405. N1, 750. X2, 375. N2, 750. And we need to check that P1 is greater than P2. Calculate. As simple as that. I got Z to be 1.55 and the p-value to be 0.0605. Again, guys, please go back. I know you listen to me, it might make sense to you as you listen to the instructor, but the only way to find out whether you really grasp the stuff is just to go back and do them yourself. So redo those problems and you already have the answers. You have quite a bit, just of worked out solutions. So I would just go and do it. And if I have any problems, I'll check the answers. So the p-value is 0.06. What is alpha here? I didn't read alpha. 5%. So you guys agree with me that the 5%, this is greater than alpha. If I give you alpha 10%, you would reject HO, but here it is 5. Fail to reject HO. Fail, you start with there is not enough evidence at the 5% level of significance to support the claim that the proportion of potential voters I'm just going to write it down, that the proportion of potential voters was greater in group 1. It means the reminder probably didn't work, didn't make any difference. That's what it means. So that's the question 4, guys. Let's pick another question. During a national presidential campaign, Professor Adams asked each of his political science students to do the following project. Before each upcoming national debate, select 9 friends to do the following. Before the debate, rate the Republican candidate on a scale from 0, very negative, to 10, very positive. Then after they have watched the debate, rate the candidate again on the same scale. Mary did the project using a random sample of 9 of her friends. The results are shown actually in the next page, guys, in the accompanying table. Use a 5% significance level to test the claim that the ratings before and after the debates are different. Okay, different actually makes it easy. You don't need to worry about it greater than 0 or less than 0. So there you go, guys. These are the results. Okay. We need to check if the results were different before and after the debate. That means the debate did make a difference, just in changing, just the people's views of the person who was running for election. So what do we do, guys? We need to do the difference here. Because it is the same person before and after. Here's the hint for you guys. Before and after means the samples are dependent. It means you have to do the difference and do a t-test against 0. This is section 8.3. So that's a negative 2. 9 minus 7 is 2. 0, negative 2, negative 3, negative 1, negative 2, 2, and negative 1. Now, can you guys tell me what the null and the alternative hypotheses are going to be now? Let me just go here and put number 5. So what do you think, guys? HO and HAs are going to be. I'll put mean of the difference. I'll write it like this. I'll put a 0 here. And can you guys tell me the signs?
Equal, not equal?
Yes. Because he said they are different. So the difference is not 0. That's the claim. If he says different, just not equal to 0. If he says the same, then mu of d equal to 0. And then the claim will be in the null hypothesis. So input differences in L1. Let's put him in L1. Don't be shy, guys, of participating. Actually, you'll make the lesson more interesting if you participate. So stat, edit. And I'm gonna clear the lists and put them in there. Let's put it.
I have a question.
Yes.
When you're doing a question like this, like when you have to find the differences between 2 dependent variables, are you always going to use t-test?
Always.
Okay.
100%. Take a note, everyone. It's always the t-test against 0 also. Not always the t-test, but against 0 as well. So when you put the null hypothesis, you're going to put the value 0 there. So negative 2, that's a good question. And the hint, guys, to know that this is what you have to do when he gives you a table with 2 rows, one that has a before and what has an after for the same people, then you know they're dependent, then you know it's section 8.3. Negative 1, negative 2, 2. Actually, it seems to me that the ratings of this person running for election went down because we're getting, you know, just negative numbers, but he's not asking me to check whether they went down or up. He's just asking us to check they are different. That's all. Okay, so we're gonna go, guys, to stat, tests, t-test. As I said, I'm gonna stick to my words. Data against 0. Remember, don't forget to change this one to 0 when you do section 8.3. It's always against 0. My list is in L1, not equal to, and then hit, I'm gonna do a draw for you guys. Oh, too much p-value here. So we're gonna fail to reject HO, of course. So T is negative 1.306. Run t-test. mu0, 0. Data. And then T equals negative 1.306. And p-value is 0.2280. Okay, I'll show you what I'm doing here, which is more than alpha, guys. Fail to reject. HO. There is not enough evidence at the 0.05 level of significance to conclude or to support the claim, if you want, that the ratings are different. Maybe you would tell me, I see that the ratings have changed and they went down, so they should be different, but probably not significant enough, guys, to say that there is a difference. And I'll give you an example. If someone is taking a medication to lower cholesterol, let's say that person's cholesterol total was 250 before taking the medication. And when they took the medication, it went down to 245. So yes, it did go lower, but only by 5 points. Is the 5 points, you know, is this a significant difference? Probably not. It's not too much difference. It doesn't make, you know, just, but maybe the hypothesis is going to reveal probably there is a difference, but 5 points doesn't change anything. You need to change it by 50 points or 60 or 70 points, you know, to improve, you know, just cholesterol levels in this example. So that was question 5. Let's pick one more. 16. 2 different methods of teaching French vocab were tried on 2 independent groups. Method 1 was used with a group of 40 students selected at random. And method 2 was used with another group of 42 students selected at random. So let's write down the details. Okay, so question 16. Method 1. Method 2, guys. N1, how many in the group? 40. And N2, 42. After 1 month, the same vocab test was given to both groups. The average score out of 100 for the group using method 1 was 89, so X1 bar. And then he's gonna give us the X2 bar as well. With a known population standard deviation, guys. So it's sigma 1. Look, this is the key word, population standard deviation. The average score for group 2 was 86 with a known standard deviation of 5.5. Test the claim that the students taught and with method 1 performed better on the vocab test at 1% level of significance. Okay, can you guys help me write the null and the alternative hypothesis? He says, test the claim that students perform better with method 1. Yes. So it's not a proportion. What are the signs, guys? Better means what?
Greater than.
Greater than, very good. And it should be in the alternative. I know some students ask me before, sometimes you start with the null, sometimes you start with the alternative. I start with the one in question, always. So he says greater than, I know greater than can't be in the null, so I have to put it in the alternative. So if it is a greater than, then you know the null will be less than or equal. Remember, the alternative has to have one of those signs, and the null will have the opposites. Always, always, always. And the claim is right here, guys. And this is 2 sample z-test. And if you ask me why z-test, because he gives you sigma 1 and he gives you sigma 2. It's a 2 sample z-test. Let's run the test together. I mean, let's say, guys, even you make a mistake and you do a 2 sample t-test. If you do a 2 sample t-test, look, you're going to come up with the question pooled. And if he didn't give you the answer to pooled, you're not going to be able to proceed because he didn't say anything about. So you know it's not a 2 sample t-test. It must have been the z-test. And look, the z-test stats. Okay, he wants sigma 1 and sigma 2 first. So it's a 4 and a 5.5. X1 bar is 89. N1 is 40. X2 bar is 86. N2 is 42. And what else? Okay, we need to check that mu1 is greater than mu2. So it's a number 3, guys. Make sure to select it and hit enter. I've seen from my experience teaching this course, students see like, you know, this is selected, they don't do nothing, but it's actually probably it's not selected. So you have to go to it and press enter and calculate. Let's do a draw. We'll show you the p-value. So Z is 2.83. And p-value is 0.0023, which is definitely less than alpha, guys. Reject HO. There is enough evidence at the 0.01 level of significance. If someone asks you what's the level of significance, it's the maximum allowable probability to make a type 1 error, means the chance of rejecting HO when it is true. Remember, in statistics, we cannot be 100% sure. So there's always a chance of errors. You can even see in the polls, guys, that we had prior to the election, some polls were not very accurate. Turned out, you know, just that the true outcomes were very different, you know, just from what the polls said. So there is enough evidence at the 0.01 level of significance to support the claim that students perform better with method 1. Okay, so that is the review, guys, for chapter 8. On Monday, I'll also review a few more exercises with this if you have any questions. And I'm gonna just now go to the algebra needed for chapter 9. So I'm gonna stop the